Hi, welcome back to the line integral and the problem solving sessions. And today we're going to take a look how to find the line integral when the curve C is a space curve here. All right. So now let's do a little bit of refresh. Our first video we talk about is how to do the line integral when the C is a plane curve, right? So we did three different type of the problems. Like the first one, the parametric equations already defined for you. We say that's the most easy type of the problems, right? You can just use the formulas here and try to do it. So here is the formula for the one they already know, the parametric equation. Then the second one is here. So if you have 2 points on the plane, how do we define the parametric equation for the line? Then the last one is how do I do the derivative? I'm sorry, the integration with respect to the x here, right? All right, so now we are take a look. So how do I do the line integral when the C is in the space curves here? All right, so let's go ahead and get started here. So the first things here for the line segment is very similar like we did in the plane curve. So the first things here, we need to know what is our directional vector, right? So our directional vector, so will just be 1 minus 3 is negative 2, and the 2 minus 1 is 1, 5 minus 2 is 3. This is our directional vectors here. And then from the chapter 12, we talk about how do we define the line in the three-dimensional space. Now we put the parametric form, so we know the parametric form for the line, we can pick a point, we say 3, 1, 2. Is that right? So we say x is equal to the 3 minus 2t, then y is equal to 1 plus t, and the z is equal to 2 plus 3t. All right. So now after we, after we defined, the parametric equation, then we just plug into our formula. So what is the dx dt is here? So the dx dt will just be equal to negative 2. Then the dy dt will just be 1. Then dz dt will be what? Will be 3, right? So now we can do this. So we can do just like we did in the two, the two variables. So here we have x, y, z's. So first I put the y. So y is 1 plus t. So I replace everything with parametric. So 1 plus t squared. Then the z is 2 plus 3t's, right? Then times the dx dt. So it's negative 2 square plus dy dt is 1 square, then plus dz dt. So it's 3 and 9 squares here. Okay, so then you do dt. So where is the t? Remember we said for the line segment, right? So if this is line segments here, so your t, okay, will start at point 312. So t, when the t will start at 0, and then the t will end at, so a t will end at where? End at 1, right? Okay, so that's why when the t, so 3 minus 2t going to end up at 1, start from 3, end with 1. And so that's why t equal to 1. Then when t equal to 1, the y going to be 2, right? So we know that is the t going to be from 0 to 1. So we put this is 0 to 1. So for here, this one's here, we can just FOIL it. So this is 1 plus 2t plus t squared. and then 2 plus 3t dt's, right? Now what do we have inside here is the square root of the 14 dt. Don't forget t is from 0 to 1 here, okay? And now you can just continue FOIL. So this will be 2 plus 4t plus 2t squared plus 3t plus 6t squared plus 3t cubed. Right, and then put the square root of the 14 here, the dt's here. Okay, so now you can combine and integrate. So now everybody should know. So this will be 0, 1. You can put a square root of 14 in the front. So this will be 2 plus the 7t, right? So 2 plus 7t here, plus 8t squared plus 3t cubed. All right, then you integrate, and then you can use the power rule. So finally, after you integrate, then you put the upper bound minus lower bound, right? So then the final answer for this one going to become to the 107, 12 square root of the 14. Okay. All right, so this is this problem. So for the second problem, so for this ones here, they already give you the parametric equation. So you can just directly substitute and then use the square roots of the dx dt, dy dt, dz dt's, right? Because we said here, we want to integrate with respect to the arc lengths here, right? So we can use our formula, and so this one will be the straightforward, and so this one we can just say here the dx dt. So let's say here, let's take a look. The dx dt for this one is just 1, then the dy dt for this one will be the negative 2 sine 2t. Then the dz dt will just be equal to the 2 cosine 2t, right? So we do the dx dt, dy dt, dz dt, then we plug in the functions, and now in here, t is from 0 to 2 pi, so we can put in here, then the x squared, so we'll say t squared plus y squared is a cosine 2t square plus sine 2t squares, right? So let's you plug in this function. So you plug in your, parametric equations here. This is a parametric equation. You plug in these functions here. All right. Then you times the square roots of the dx dt square. So it's 1 square plus 2 sine 2 squared 2t, I'm sorry, it's 4 after you square that, then plus 4 cosine, okay, squared 2t, right, and the dt. So then I know here this one will be pretty straightforward. This is 0 to pi, then this will be the t squared plus 1. Right, because the cosine square plus the sine square, it will be 1 here, right? So it will be the t square plus 1. And then the inside here, all right, so the inside here will be, let's take a look at this one. All right, so this will be 1 square plus 4. Then you have a sine square 2t plus cosine square 2t, okay, dt. Then by the trig-Pythagorean theory, so by the trig-Pythagorean theory, so we know this one is equal to 1, right? So this one it turns out to be a very easy. So the whole things here, the whole distance will just be what? Square root of 5. Okay, so now we can do here just be the, so it will be the square root of the 5, then the 0 to 2 pi, then the t squared plus 1 dt. So this will be a pretty straightforward. So then this will just be the square root of the 5, then you the t cubed over 3 plus t, right? Then your up bound is 2 pi, lower bound is 0 here. All right, so after you substitute the upper bound minus, you substitute the lower bound. So the final answer for this one will be the square root of the 5. And this is a over 3 pi cube plus 2 pi. Right? So it's a over 3 to 2 pi, okay? Pi cube plus 2 pi. All right, that's it. So the problem number 3 here is exactly the same, right? So you plug in the function. So I will skip this problem and let's take a look at this ones here. Okay, this ones, they tell you I need to do a line integrations like the c is y plus z, the dx, y plus z, the dy. Okay, so now let's take a look here. Okay, so this problem is a little bit interesting. So in here we have 2 line segments here, right? So the first line segment is from the point 0, 0, 0 to 1, 0, 1. Okay, then after 1, 0, 1, then is from 1, 0, 1 to 0, 1, 2 here. Okay, so that is we have 2 line segments. And then the other things interesting here is, like when you take a look at the integration here, so for this part is respect to x, this part is respect to y, this part is respect to z. So it's not the integrate by the arc length here. All right, so because so we call this first segment is 1, this is segment is 2. All right, so let's take a look now. Let's write it down the segments 1. So the directional vector for segment 1 is just 1, 0, 1, right? So this point minus that point. Okay, so then choose the point x at 0, 0. So I have x is equal to what? 0 plus t, right? And the y, I have what? I have 0 plus 0t. So basically it's 0, all right? And then I have z is 0 plus t, so it's t again. So now let's take a look at dx here, going to be dt, right? Because I'm going to do the x, y, and the z. Then the dy's here will just be the 0 times dt. And the dz's here is going to be dt. Okay, now let's take a look the segment number 2 here. So the directional vector will be -1 and the 1 and the 1s, right? So now the x's here will be 1 minus t, then y's here will be 0 plus t, and the z here will be 1 plus t. Okay, and now let's do the dx dt. So the dx here, this will be negative dt. Then this is dy's here, this is dt. And the dz here, this is dt. Correct? Okay, so now let's see here, of course, because this is line segments for both functions, the t is from 0 to 1, and for both segments here, this one is t is from 0 to 1 here. Okay, so now let's try to write here, okay? So for this integration, all right, so this integration will be equal to, okay, so I'm going to separate that. So be the C1 y plus z dx plus x plus z dy plus x plus y dz for the segments C1, then plus the segments C2, it will be the y plus z dx plus x plus z dy and plus x plus y dz here. Okay, so for the C1, we use this ones here, right? 0 to 1. So y plus z. Y is 0. Z is t. So it's 0 plus t. Then the dx is dt. All right. And then plus x plus z. All right. So x plus z. So it's t plus t. Then the dy is what? Is the 0 times dt. So this term basically is gone. So x plus y, so it's t plus 0. Then dz is what? dt. Right? Okay. Now let's take a look here. The second segment here. So this is the 0 to 1. Also, then we need to use this parametric equation. So y plus z, right? So y plus z, so it will be t plus 1 plus t. Then the dx, right? dx is here, so it's a negative dt. Then plus x plus z, x plus z, so will be 1 minus t plus 1 plus t dy, dy is dt. Then plus x plus y, so x plus y, so it's 1 minus t plus t times what? Times dz. So dz is dt. All right, so we can simplify a little bit. So this one's here, this is 0, 1. All right, so this is 0, 1. And this thing's going to disappear. This one going to disappear because it's 0, right? So you have 1t, 2t's here. So for the how many t I have? I have a 2t dt. All right, so it's become pretty easy. Now the second one's here. So you have negative dt. Okay, so let's just simplify it a little bit. Hopefully it will help us to see. So this t and this t, so this is a 2. And this t and this t, this is 1. And this is a negative 2t, negative 1. All right, so 1 and 1 cancel. So it's a 2 minus 2t. Right? So it's only have a 2 minus 2t here. Okay, so now I have integrated 0, 1. Then this is a 2 minus 2t dt. Okay, so now here this is just a t squared, 0, 1. Then plus 2t minus t squared. Right, so minus t squared. So this is from 0, 1 here. All right, so the final answer, if you put it in there, and you will get this is a truth here. Okay, so that is for the linear line integral over the plane, over the space curves here, right? So we also talk about the 3 different types here. First one is you need to find the parametric equation by yourself. And then the second one, they already provide the parametric, then will be pretty easy. Just plug in into the formula, the dx, dz, dy, dz, dz, dt. dx dt, dy dt, dz dt, and then to the integration. The last one, this is interested because the last problem is interesting. Why? Because they have 2 segments, right? So you need to separate and integrate it. And then the integrations here, you need to be careful is respect to the dx for this function, dy for this function, and the dz for these functions here. All right, okay, that's it. And so this is the line integral over the space, the curves here. Hope this help to work on the further problems here. All right, have a good day. Okay, bye-bye.